Yeah, I'm Harald Meyer. I'm working for Cumulosity, mostly on topics like co-innovation together with customers, but also directly on customer projects. And what I want to talk to you about today is how we can use Opc-Ua together with Cumulosity, and specifically through ThinEdge as well. So this is how Opc-Ua in general works in Cumulosity. So Opc-Ua is a protocol that's used, for example, in shop floors, but also, for example, in wind turbine setups. So it's quite a flexible protocol. And the way that we are supporting it is that we have the Cumulosity Opc-Ua gateway, which is a standalone component that's running inside of your network, being connected directly to one or multiple Opc-Ua servers. And it then is connected to Cumulosity to actually hand over the data to Cumulosity, and also to transfer back interactions with a server from Cumulosity to the Opc-Ua server. And by default, all of that interaction between the Opc-Ua gateway and Cumulosity is done directly. So once you install the Opc-Ua gateway, you go through a bootstrapping process to register it in Cumulosity. Then in the Opc-Ua user interfaces in Cumulosity, you connect Opc-Ua servers and define device protocols to define what kind of data should be sent from the Opc-Ua servers to Cumulosity. And then finally, also the actual transfer of data is also done via directly to Cumulosity. And one thing that we already support, besides this standalone mode, is what we call the ThinEdge mode. So instead of doing the initial bootstrap and registration itself using Cumulosity, the Opc-Ua gateway in this mode uses a ThinEdge to which it is connected already. So both ThinEdge and Opc-Ua gateway are running locally on premise. And now actually the Opc-Ua gateway, instead of going through the Cumulosity registration process, gets the credentials to connect with Cumulosity from ThinEdge. And this makes basically operation of the Opc-Ua gateway simpler for you, because you don't have to go through the initial bootstrapping process and then later on manage these credentials. And we even have a version of the Opc-Ua gateway which comes as a container that works directly with ThinEdge. So this is already working. And the new thing that we will have available very soon, so you are getting a preview of something that will be released in the next couple of weeks, is the ability to also use ThinEdge to transfer the data. So after the Opc-Ua gateway has been configured with device protocols to know which data to send to Cumulosity, it will then send the data no longer directly to Cumulosity, but instead it will send the data to ThinEdge, to the MQTT broker. And then in ThinEdge, you can either have the Cumulosity mapper, which is a standard component, directly map the data into Cumulosity format and send it to Cumulosity, or you also have the option to have other custom modules running in ThinEdge that take the data, transform it, and only then send it to the Cumulosity mapper. So this gives you much more flexibility in how you actually want to send Opc-Ua data to Cumulosity, because you don't have to rely on just what device protocols support, but basically if you need to have some custom functionality to, for example, filter data or aggregate data, you can already do that directly on ThinEdge and only afterwards send on the data. As a part of this functionality, we actually also have another improvement. So in its standard mode, Opc-Ua gateway will send each measurement that it gets from an Opc-Ua server to Cumulocity as a single measurement. And with this new forwarding mode, you can actually bundle multiple measurements that are read in the same cyclic read into a single measurement, like you know in Cumulocity, where you can have multiple fragments and then multiple series in these fragments to have complex measurements that contain multiple data points. So that's something that you can configure separately for your gateway if that is something that you want to do. So with that, let me quickly go to the demo. So I have already started ThinEdge to save on some time. So ThinEdge is already connected to my tenant, and it's running locally on my computer. At the moment, it doesn't have any child devices, as you can see. So first thing is I'm going to start the gateway. This will take about 1 or 2 minutes to actually be up and running. So if there are any quick questions right now, just jump in and raise your hand. If not, I would actually, well, okay, there is a hand.
Yeah, have to be fast here. So just the registration of the Opc-Ua hierarchy just still works as before, or is it also like mapped to ThinEdge now?
So the first step of the gateway itself, that actually uses ThinEdge capabilities. So you will see that the gateway is registered as a child device. The actual registration of the child devices below that hierarchy, that's still managed by the Opc-Ua gateway.
Okay, so all the synchronization of the nodes still happens as before.
Exactly, yes.
Okay.
Okay, so then I can quickly show. So this is how the gateway configuration looks like now. It's pretty much the same as before. New is in the ThinEdge configuration, you now have an option to use it also for data forwarding. So then ThinEdge will be used to send the data to Cumulocity. Otherwise, it's still using the direct communication. And the other new thing is that the ability in the mapping section to merge cyclic reads into single measurements and events. This is only supported for ThinEdge mode. So this will be ignored if you are using the standalone mode. In that case, the data will still be sent as individual measurements. So I think now it's still starting up. Not sure why it's taking that long. So if Mario or somebody else has another question, we should have the time for that.
Harald, Marco here. So I need to use ThinEdge mode for registration, also to use the batching.
Yes.
Okay.
Because
okay, but this is also working without containerization, etc. This, okay, yeah, that's fine.
Yes, that's correct. So yeah, but it basically needs to be configured initially with ThinEdge, and only then it will use ThinEdge also for the data forwarding. Okay, so we see that it's making some progress. Let's see if we can already see the gateway being registered. Not yet. So that, I think it should be pretty close now. Okay, now it should be. Yeah, now it's available. So if we go back to our thin edge, we see it has a child device, which is the actual gateway. And we see that's available here. So now the next step is that we actually need to connect an Opc-Ua server to our gateway. I have that also running locally on my computer. So I can configure that. I don't have to use any kind of security here because I have not enabled that. So I have that available now. And that will now take in the background also, hopefully only 1 or 2 minutes. I hope that's a bit faster. But while that's going on, we can actually have a look at a device protocol that I created. So this is a device protocol that's working with my Opc-Ua server. And it's listening to 3 different variables. So one called random, sawtooth, and triangle. And as I mentioned before, the bundling only works if you're using a cyclic read. So otherwise, it will still send individual measurements. And the cyclic read is also basically the configuration package that defines what is being bundled together. So by default, you have this default data reporting mechanism. And if that's used, everything is being bundled together in a single measurement or event. You can selectively switch to a custom data reporting mechanism for individual variables. Then you will actually only get the ones with the same custom data reporting bundled into the same measurement. So as you can see here, the first variable, it's mapped to a measurement, to an alarm, and to an event. Then if we go to the second variable, we see that it's also mapped to a measurement in the same fragment, but using a different series, and also to an event. And then the last one, the triangle one, that is only mapped to a measurement, and that's in a different fragment. So we should see a measurement coming out of this with 2 fragments, and one of the fragments contains 2 series, and the other one contains just 1 series. So let's see. Okay, so it's ongoing, but I think it should be pretty close. So it's getting a bit faster towards the end typically. So once that is available, I will be able to enable the simulator, and then we can see what's actually going on. So scanning is done now. Mario, you can still squeeze in a question if you want.
Thanks. The measurements that you sent, you said that they are published via the standard TE topics. Is it possible to configure this if I don't want to immediately send the measurements?
Yes, that's not something I'm going to show today because that's still work in progress. But you can actually use custom actions to configure a different topic to send the data to, and we will also support completely custom MQTT brokers, so that if you have a broker like the MQTT service in Cumulosity or a complete standalone broker, you can send the data there and also configure the topic that the data is being sent to.
Thank you.
Okay, so yeah, now we see there's a few more things. I'm not sure why it's still scanning.
Harald, one question.
Yeah.
So which measurement type is used for the batched measurements? Which name is derived?
The type is by default Opc-Ua measurement, but in the configuration you can override that type.
In the gateway configuration.
In the gateway configuration. So it's a single measurement type used for all.
And then also
kinds
the
of measurements.
fragment has that, so meaning all the values that are in the device protocol above the series are ignored then.
No, that's not correct. So inside what you configure as a type in the device protocol for the measurement, that's used as a fragment in the combined measurement.
The combined measurement.
I'll show that to you once it's
okay, cool.
It's actually done. It looks like it actually scanned the Opc-Ua server again, but it should be done now. So now it's done again. Let's hope it's done for good now. So let's see if, I don't think it has applied the simulator yet. That's happening right now. Now it's scanning again. Why is that doing?
Scanning did not fail, right? In that case,
No, it's concluded is that successful. So I'm not sure. Why it's doing that.
It's counting down, it's verifying some nodes, I think.
No, what does this mean? It's basically currently syncing the address space. That means uploading this.
Yeah, but it's doing it for the third time now. Let's see if it's, I mean, it should only be a minute or so till it completes. Let's see if it actually does not repeat again.
however, on the parallel, it tries to apply the device protocol probably.
Okay, do you think I should disable it maybe again?
I would now keep, it's just 800. I would just keep it going.
I see. Have you changed it?
I'll wait to activate it until it's scanned the whole address space. So let's see. It doesn't look like it's starting again. Okay, so now let's activate the device protocol.
Normally, you can keep it enabled. It's applied automatically.
Yeah, I actually wanted to actually wait until, but of course, if it has to scan 3 times, I think it just wanted to be thorough this time. But now, yeah, we should actually see that it has applied the device protocol, and we see if we go through the whole hierarchy, starting at thin edge, we see that we still have the gateway as a child. Then as a child of the gateway, we have our Opc-Ua server, and that now has as a child the simulator device protocol. And if we look here, we see that it has created an alarm which has been cleared. So no, it has not created the alarm yet. Let's see, okay, so it has created the event. So as I said, the event is also merged. So we see the contents of both events merged into a single event. And we should see in the measurements, we see there's the value fragment, which has two different series in it. So simulation and sawtooth. And we see the value true fragment, which has just one value in it. So let's see if the alarm has now been raised. This could be if the value is still below 0. No, we see it has actually been raised and cleared twice. So to answer Marco's question, if we look at the actual data that is being produced, let me take the device ID. So that's the last measurement that has been produced. And as you can see, it has one type Opc-Ua measurement. There's one fragment called value. That's basically what was called the type in the device protocol. And the two different variables, sawtooth and simulation, that shared the same type are sent in that one. And the third variable called value true, which has just one variable in it, is just containing a single series.
So the type is no longer referring to type as a measurement type, but to the fragment only.
Yeah, because actually what you configure as a type in the UI internally is used for both the type and the fragment. And here we removed basically the type because, I mean, you can't have multiple types for the same measurement.
Yeah.
There are some ideas to streamline also the user interface in the future to make this more flexibly possible. But at the moment, the type is essentially what has been configured in the gateway configuration. And as the type isn't really that important anyway, that's basically a good intermediate solution that we have at the moment. Let me just spend 2 minutes to quickly go through the outlook. So as I said, this is something that will come up as available in the next couple of weeks. As a part of that release, we also want to provide the ability to have connections to generic MQTT brokers like the Cumulosity MQTT service. So this should come at the same time. The second thing that we are considering is using the Cumulosity proxy feature of Thin Edge, because then the Opc-Ua gateway in Thin Edge mode would no longer have to maintain its own credentials, but it would just rely for any Cumulosity communication on the Thin Edge proxy. This is something which is planned, but we do not have it committed for a specific release yet. So it's not clear when exactly this will become available. And finally, we have some ideas of having a more lightweight version of the Opc-Ua gateway, where actually we do not scan the whole address space and store that in Cumulosity and then match device protocols against it, but instead focus in the gateway on just fetching data from Opc-Ua and then use other mechanisms like the mapping feature in Thin Edge that Ruben mentioned in the beginning to do the actual data mapping for you. This is really, at the moment, just an idea. I mean, you've seen the scanning taking longer than I anticipated today. That's one of the reasons why we are thinking about things like this. But at the moment, we don't have any concrete plans of implementing this. And also, to be honest, it's just a high-level idea. So we don't know for 100% what the concrete requirements would be here. So if this is something that basically a customer is interested in, we would be very much interested in getting their feedback on this. So please contact us directly, or whoever you know in Cumulosity if this is something you're interested in or something where you want to share some of your requirements with us. So while I'm jumping to our last slide, do we have any additional questions? Okay, if not, then I think even